Ever wondered about the tiny, invisible particles that make up everything around us? That's what quantum mechanics is all about. Welcome to this extraordinary realm where the laws of classical physics don't apply. Quantum mechanics serves as the rulebook for the behavior of these tiny particles, such as atoms and photons. Picture a magical world where a particle can be in two places at once or pass through walls. Sounds fanciful, but this isn't just fantasy. Quantum mechanics isn't just theoretical, it's the bedrock for futuristic technologies like quantum computers and the ultra-secure quantum cryptography. Intrigued? Let's dive deeper into the quantum rabbit hole. In the world of quantum mechanics, things are a little strange. Take the principle of superposition, for instance. It's like being in two places at the same time. Imagine you're at home and at the grocery store simultaneously. Sounds impossible, right? But in the quantum world, particles can do just that. They can exist in multiple states at once until observed. Now let's talk about another peculiarity: quantum entanglement. It's like having a pair of magical dice. No matter how far apart you throw them, if one lands on 6, the other will too, instantaneously. In reality, particles can be entangled in such a way that the state of one immediately affects the other, regardless of the distance separating them. These aren't just fanciful ideas. They're fundamental aspects of the quantum world. A realm that's as fascinating as it is bizarre. Isn't it fascinating how the quantum world operates? But how do we know all this? One of the most famous experiments in quantum physics is the double-slit experiment. It's a straightforward setup with particles shot towards a barrier with 2 slits. But the results are anything but simple. The particles, which could be electrons, photons, or even atoms, seem to act like waves when they pass through the slits. They create an interference pattern on the screen behind the barrier, just like waves of light or water would. But here's the catch. These are particles we're talking about, not waves. So how could they possibly create a wave-like pattern? Here's where the quantum weirdness kicks in. The particles aren't just going through one slit or the other, they're going through both at the same time, acting like waves. And when we try to observe which slit they go through, they behave like particles again, going through one slit or the other, but not both. This experiment is just one of the many that show the strange behavior of the quantum world. So, does quantum mechanics have any real-world applications? You may wonder. Well, in fact, it does. Quantum mechanics isn't just a theory that lives in textbooks and labs. It's the backbone of many technologies we rely on daily. Take lasers, for instance. The principles of quantum mechanics allow us to understand and manipulate light to create lasers, which are used in everything from barcode scanners to eye surgeries. Then there's semiconductors, the core component of our electronic devices. Their function hinges on quantum mechanical phenomena. Let's not forget about MRI scanners. They are able to create detailed images of our insides, thanks to quantum mechanics. And looking towards the future, we're seeing emerging technologies like quantum computing, which holds the potential to revolutionize how information is processed. And then there's quantum cryptography, promising unparalleled security and information transfer. Quantum mechanics isn't just a strange theory, it's a vital part of our modern world. So, what have we learned about quantum mechanics today? We've ventured into a realm where the principles of classical physics cease to apply, and instead we have a fascinatingly different set of rules, the principles of quantum mechanics. We've explored the quantum world, where particles can exist in multiple states simultaneously until observed. This enigma was demonstrated through the double-slit experiment, a cornerstone of quantum theory. It showed us that particles can behave both as particles and as waves, defying our everyday understanding of reality. We also delved into how quantum mechanics isn't just an abstract concept, but it has real-world applications. We see its influence in technology like lasers, semiconductors, and even in our understanding of chemical reactions. Quantum mechanics might seem strange and mysterious, but it's an essential part of understanding our universe. Thank you for joining us on this journey into the quantum world. If you've enjoyed this journey into the quantum world, then we have a small request. Please hit that like button and subscribe to our channel, QuickExploreQuests. Your support is what fuels our explorations into the fascinating realms of knowledge. Each like, each subscription, helps us in creating more content like this, content that dives deep into the mysteries of our universe and beyond. So don't forget to hit the bell icon too, so you never miss out on our future quests. Thank you for watching, and we can't wait to see you in our next video.